Okay, so let's look at another example for 3.3. So this is given the mean, standard deviation, and z-score, find the x value. So in the beginning of 3.3, we found the z-score. So this time we are finding the x value. So in this first example, IQ scores have a mean of 100 and standard deviation of 15. Steve-O's IQ can be described by z equals negative 1.5. What is his IQ? Round to the nearest tenth. So this is going the opposite way. So you don't have to write this whole thing down. I would just write down the important information. So like the mean is 100. Standard deviation is 15. And the z-score is negative 1.5. So if you're given a negative z-score, that means that it's going to be below your mean. So we could use that same formula. So let's look back at our notes for that formula. Z equals x minus x bar over s. That's right here. So it's saying it's negative 1.5 standard deviations. Well, 1.5 standard deviations below the mean. So if we work this problem backwards, we could plug in this formula. Let's see. We would take, let's see, our z-score is negative 1.5 equals x minus x bar 100 over negative 1.5 over 15. Whoops. Over 15. There we go. So we could work this backwards. We're using that same formula, but we're solving this equation. So going back to solving equations in algebra class. So yeah, multiply by 15. So you're taking your standard deviation and multiplying by your z-score because it's negative 1.5 standard deviations from your mean. So when we multiply that, Yep, and then we will add 100 to both sides. $77.5 is that value. So Steve-O's IQ score is 77.5. So he's on the lower end. If you can work it out a different way in your head, how it makes sense, you can do that, or you can use this formula. All right, let's look at one more example. Given a z-score of 1.5, a mean of 7, and standard deviation of 10, find x. I'm going to write down the important information. So this is 1.5 standard deviations. So it's above. So it's going to be above 7 by 1.5. So what we would do, instead of working it backwards this way, we could just multiply our z times our standard deviation and then either add it to our mean or subtract it from our mean, depending on if it's a positive or a negative. So you do plus x bar. That would be one way of working it out if you don't want to use that formula. So 1.5 times our standard deviation, which is 15. Move the decimal over one place. Plus our mean, 22. So x equals 22. So I did the exact same thing as this, just I had an equation to solve here. This one, I wrote it out with z times s plus x bar, which is the same thing. Multiply times s on both sides, and then add your mean to the other side. All right. So that gives you an example of what a problem will look like on the review test or 3.3.